Thanks for joining, everyone. We'll just give it a couple of moments to let people join, and then we'll kick off. Okay, so thank you everyone for joining today for our AWS Sumo Logic Kubernetes Immersion Day. My name is Eddie Thompson. I am Lead Solutions Engineer for Sumo here in the APJ region. With me today, I have James Schaefer from AWS. Would you like to introduce yourself, James?
Thanks, Eddie. Hi all, I'm James Schaefer, Partner Sales Solutions Architect with AWS. I've been with AWS as a Solutions Architect for around about 2 years now. And prior to that, I worked at a number of organizations representing both partners and customers of AWS. Thank you.
Excellent. Yeah, so I help out a lot of our customers in region with their observability challenges. And yeah, today we're going to drill into what we can do specifically around Kubernetes and AWS CKS and Sumo Logic. So I'll jump into the slides here, and I might hand over to James for this first part of the presentation.
Awesome. Thanks, Eddie. Thanks very much. So yeah, the goals of today's session, as per you see on your screen, at a high level, provide customizable experiences to discover and learn. We're going to help prospects and customers dive into services and solutions, and we're going to give you some hands-on time and guidance for solutions architects and trainers alike. Next slide, please, Eddie. Great stuff. Oh, we're on today's agenda. Do you want to cover that one?
No.
Oh, there we go. Yep.
No. Yeah, so it's pretty straightforward here. So we've got the welcome, quick introduction. We're going to go through AWS Kubernetes and EKS, and then we're going to have some time where we can drill into some hands-on labs. You can log in and have a play with the Sumo environment for Kubernetes. Then we'll have some time for some questions at the end and wrap it up.
Great stuff. So before we get too deep into the Sumo Logic and AWS technology solution, I'd like just to talk about Kubernetes at a high level. So Kubernetes is an open source software that allows you to deploy and manage containerized applications. Importantly, it allows you to do this at any scale, from small developer-centric environments through to large enterprise production scale. You can use it to run your containerized applications anywhere without needing to change your operational tooling, whether this is on-premise, in the cloud, or a hybrid environment. At a high level, Kubernetes works by managing a cluster of compute instances and scheduling containers to run on that cluster. Containers run in logical groupings called pods, and you can run and scale one or many containers together as a pod. The Kubernetes scheduler is a process that assigns pods to nodes, and nodes are the worker compute instances within the cluster. In a typical Kubernetes implementation, we'd see Kubernetes control plane determine the when and the where to run your pods. It manages traffic routing and scales your pods based on utilization or other metrics that you define. Kubernetes automatically starts pods on your cluster based on their resource requirements and automatically restarts pods if they or the instances they are running on fail. We find Kubernetes is popular with developers because it allows them to take advantage of a broad set of ecosystem tools. It integrates drivers to configure networking and storage for your applications. It also has a consistent set of open source APIs with broad flexibility. Next slide, please. There are a large number of benefits of running Kubernetes, from simplified and consistent deployments throughout environments through to huge flexibility in where you can place your workloads. However, we've heard from our customers that managing Kubernetes at scale is hard. Running clusters at production scale is complicated and requires trained people who spend a significant portion of their time managing upgrades, monitoring and scaling the control plane, deploying and managing the lifecycle of operational software, and many other similar tasks. In addition, operations teams need to ensure that their workloads are deployed in a secure manner without exposure to known security vulnerabilities, to further increase the operational overhead of running Kubernetes on your own. This operational heavy lifting doesn't directly drive the organization towards its business objectives. So by reducing this undifferentiated heavy lift, our customers are able to have their skilled team members turn their attention to developing products or offers for their customers. And this is why a lot of our customers have come to rely on Amazon to handle that undifferentiated heavy lifting of securing and operating Kubernetes at scale. Next slide, please. Also, the platform you're running Kubernetes on impacts the quality and speed with which you can bring new product and offers to your customers. Your customers likely have expectations around performance, around availability and security of your product. Also, how quickly new features are introduced. If your app is down when they need it most, that has a lasting impression on your customer base. With that in mind, AWS global infrastructure is built for performance. AWS regions offer low latency, low packet loss, and high overall network quality. This enables teams to design applications to meet those tough SLAs. Further to this, AWS is architected to be the most flexible and secure cloud compute environment available today. Our core infrastructure is built to satisfy the security requirements of the military, global banks, and other high sensitivity organizations. Couple this with more than 200 fully featured services, and it's easy to understand why. Next slide, please. We see the vast majority of customers running containers in their cloud today run them on AWS, and this is around about 2/3. So to bring this together, I'd like to focus on Amazon Elastic Kubernetes Service. Amazon EKS, as we call it, is a managed Kubernetes service to run Kubernetes in AWS cloud and on-premise data centers. In the cloud, Amazon EKS automatically manages the availability and scalability of Kubernetes control plane nodes responsible for scheduling containers, managing application availability, storing cluster data, and other key tasks. With Amazon EKS, you can take advantage of all the performance, the scale, reliability, and availability of AWS infrastructure, as well as the integrations with AWS networking and security services. As per our earlier slide, our customers choose EKS because it allows them to focus on their business applications and offload that undifferentiated heavy lifting, specifically the technical operations associated with self-managing infrastructure for application deployments that add no direct business value. EKS provisions and scales Kubernetes control plane, including the API servers and back-end persistence layer across multiple AWS availability zones for high availability and fault tolerance. It automatically detects and replaces unhealthy control plane nodes and provides patching for the control plane. Amazon EKS performs managed in-place cluster upgrades for both Kubernetes, as well as updates to Amazon EKS configuration and security patches. EKS integrates with many AWS services to provide scalability and security for your applications. These services include Elastic Load Balancing for load distribution, IAM for authentication, Amazon VPC for isolation, and AWS CloudTrail for logging. Next slide, please. Eddie will dive deeper into the Sumo Logic and EKS integration. But in summary, we'll be exploring leveraging the Amazon EKS control plane logging, audit, and diagnostics logs via CloudWatch logs, together with Kubernetes source logs to gain that extra insight through Sumo Logic enrichment. So at a high level, we'll install and configure Sumo Logic collection using open source technologies to collect logs and metrics. Then we'll install Sumo Logic Kubernetes application to visualize the logs and define alerts. I'll be present throughout the session, but that's all from me for the moment. I'm going to hand you back to Eddie. So thank you very much.
Thanks, James. Yep. So if you have any AWS EKS type specific questions, feel free to sort of drop those into the chat. And yeah, I will progress through with a bit more detail on the Sumo Logic side of things. So today, I'm going to talk a bit about end-to-end observability with Sumo. So observability is something we talk about a lot. You probably hear it a lot more in the market these days than you used to, say 3 or 5 years ago. And talk a bit about what's different between monitoring and observability. So monitoring is collecting and displaying of data in queries and dashboards, and it tells you something is wrong. So more specifically, monitoring is looking for things that you know to look for. You're saying, I'm going to look for my CPU eclipsing a certain threshold, or I'm going to look when my error rate eclipses a certain threshold. You've defined something and you're looking for that, and when it eclipses that threshold or something like that, it lets you know. But generally, you're looking for known knowns. Observability is slightly different in that it's how we infer the state of a system from what the system provides to us in the form of telemetry. So we make data available in the system that allows us to understand what is going on within our system. This may seem like a slightly semantic difference, but this is about being able to determine the unknowns when we have a problem. So we don't need to specifically define a failure case to be able to investigate an application which is observable. So the main differentiator with sort of Sumo Logic as an observability platform, there's an intuitive workflow and allows you to really sort of dive into the root cause of an incident quickly. And we sort of work through a phase approach, which we sort of call monitor, diagnose, troubleshoot. So generally, when we're monitoring, we're looking for something that we know is going to have a particular impact on a customer. So we might be looking for latency in our application, or the error rate, or the response time. But if we see something that's outside the normal bounds, there's an alert that's popped up, someone can then diagnose what the related components are really easily. And from there, troubleshoot what the underlying cause is with the components that are causing the issue that's surfacing in that sort of end user metric that we're monitoring. So if we look at a few different sort of observability workflows, we can sort of have a look at how we go through that monitor, diagnose, troubleshoot phase. So we might be monitoring things based on outliers or predictive analytics. We're looking at trending and seasonal patterns, or we might be looking at some benchmarking. So with our global intelligence service, we might be saying, hey, you've got something which is showing up here as anomalous in your environment, and you should probably check that out. Beyond that, we need to narrow down the location of where is something actually happening. So we use things like log analytics, so log reduce and log reduce values to let us see where particular anomalies are occurring in our logs, how we had a big spike in a particular error message, or a particular value in some JSON logs has had a big spike. Time comparisons. Things were working okay an hour ago, and now now there's a problem. What's the delta between the two? What's changed? And finally, going down to sort of like the phase of troubleshooting, understanding why. So log compare, being able to compare patterns across my logs in a temporal situation. So using this to see what's changed and when, and identify those underlying root causes. Log explain, being able to say that across two sets of logs, we see an increase in one when there is an increase or a decrease in the other. So really using the power of machine learning to automatically correlate that data for you. And root cause explorer. So this is a bunch of machine learning models running at once across a whole heap of metric data to help you understand underlying causes based on the topology of your AWS and Kubernetes environments as well. And we'll actually have a chance to delve into that into the labs later. So this is, I really like this quote, but we replaced our monolith with microservices so that every outage could be more like a murder mystery. In the traditional sort of 3-tier app, you used to have a fairly good sort of reckoning that there was going to be a problem either in the web tier, the app tier, or the database. So once we've broken everything out and decomposed these applications into microservices, we might have 10, we might have hundreds. Some larger applications have even thousands of microservices, and these all have varying sort of interaction profiles. So being able to intuit where a problem may be just from a couple of error messages becomes really quite difficult. So we need to rely on our tooling and our telemetry to make sure that we can actually find solutions now in a timely fashion. Okay, we've got a question there. Can you see the Q&A, James?
I can indeed, Eddie. I'm actually just going to grab some data and reply in line.
Okay, excellent. So I'll leave that one there. So Sumo Logic and the AWS Observability Solution. So AWS encouraged the use of separate AWS accounts to help manage costs and the sort of administrative boundaries and controls and sort of blast radius within their environment. And teams often have different needs and they set up things across different regions depending on needs of specific apps. So once you are in a certain account and region, there are multitudes of different services that customers can use to run their apps. So we might be looking at EC2 or databases, and these all have their own data monitoring. Now, the problem is that this sort of complex hierarchy can often leave some sort of data silos where it can be difficult to acquire a clear sort of picture of the overall AWS service health across regions and accounts. So say you have 26 different AWS services that you're monitoring and you're sort of multiplying that out by a large number of accounts and regions, that makes it a little bit more sort of complex when it comes to troubleshooting. So troubleshooting is complex in itself. You've got a lot of different services interacting in your application. And if you have data silos where you have separate sort of AWS accounts, regions, service hierarchies, it sort of multiplies out the complexity and raises the degree of difficulty. So our solution at Sumo is what we call AWS Observability. So this allows us to unify visibility, and our root cause explorer allows you to accelerate troubleshooting. So go from complexity to clarity. So I'll talk a little bit now about Kubernetes more specifically and some of the observability challenges related to that. So one of the main things about Kubernetes and one of the main things that makes it really powerful is that it's highly ephemeral. So it scales up, it scales down. We're able to have pods come and go as they're needed, as they are upgraded, and it's hard to keep up with an ever-changing deployment. It's completely different from sort of like the old world of ITIL sort of change management, where every time we had a new device coming online, we needed to make sure that we're bringing it in and bringing out of change control and monitoring, etc. We can't do that anymore. Things have life cycles in the minutes and even seconds, so it makes no sense to sort of have that stuff run through an onboarding, offboarding process. But we need to be able to keep track of it, and we need to be able to observe it. There are many different data streams, and it's hard to correlate across those data streams. So commonly for Kubernetes, you have logs, you have metrics, you have traces, and you might have some security events as well. And it's difficult to get the big picture, and also from there to zoom in. So from a couple of levels, you have how do I understand the high level health of my application and clusters? And from there, how do I zoom in to the pod or container level to troubleshoot a specific application level problem? So how does Sumo solve for these challenges? So Sumo auto discovers your environment and allows you to view your Kubernetes data through lenses that make sense for the mental model you have for Kubernetes. So that is not only through the infrastructure sort of node and pod, but also things like namespace and service and deployment, which is how your developers typically interact with that sort of data model. There's many different data streams, but Sumo allows you to kick out a single Helm chart, which will collect the logs, metrics, traces, and security events from those clusters. Make sure that the data is enriched in a consistent fashion, so your metadata fits that sort of model and makes it really easy to correlate when there is a spike in a metric. What is the pod that it relates to? Where are its logs? How can I look up the traces for an application, and where I see there's a spike in CPU usage for a particular deployment, etc. And difficult to get the picture. And as I was just saying, yeah, because of how we enrich the data streams as we process it and send it to the Sumo cloud, we can easily give you the ability to sort of zoom into the depths of the logs and identify root causes. So if you're using Kubernetes today, how many tools do you use? How long does it take you to reconfigure? Are you able to see end-to-end what's happening in your environment from the infrastructure layer right through to the application layer? So as I mentioned, this is sort of the Kubernetes data pipeline for Sumo. And I actually need to update this slide because it's missing something. Normally, there should actually be an extra line in here which says traces and open telemetry. So at the moment, the Sumo Logic Kubernetes collection chart can be installed on any Kubernetes deployment, including EKS is fully supported. So when we're gathering our logs, we have a fluent bit daemon set. Now, all of these collection methods here are all Cloud Native Computing Foundation governed projects. So these are open source projects. These are common sort of industry standards for collecting this data. So Fluent Bit runs as a daemon set. So every node you have in a cluster has Fluent Bit, and that sort of acts as a log router forwarding the data on. Fluent D, we have a plugin for Fluent D, which speaks to the Kubernetes API server and grabs the cluster level events. Metrics, we use Prometheus operator to expose the metrics from Kubernetes, and Falco is an optional kernel level anomaly security anomaly detection tool that you can run to get a greater sort of security visibility picture of your cluster as well. Now, the secret sauce part here is this enrichment pipeline. So all of the data that flows through to Sumo goes through this enrichment pipeline, and that's where we sort of stamp all the metadata on the related things. So not only do we know which node or pod or container a log came from, we know which service, which deployment, which namespace, and any other sort of label data that you wish to assign to your Kubernetes workloads. We can absolutely sort of pull that metadata in as well, which gives you sort of like a really rich and complex picture when you go to actually analyze that data and sort of use it in dashboards. It's all deployed via a single Helm chart, nice and easy, and everything gets encrypted and compressed and sent up to the Sumo Logic cloud. So the Kubernetes app for Sumo Logic runs within our Explore view, and it makes it really easy to manage and monitor multiple clusters. It gives you centralized metadata enrichment, visibility into the worker nodes of a Kubernetes cluster, and importantly, I mentioned those namespace deployment and service views, so allowing you to slice that data and organize it using the mental model that people have for Kubernetes. Everything's dynamic and live updates. So for those ephemeral workloads, you can see things come and go as they're sort of there in your environment. It's cloud native computing foundation standards, and it has out-of-the-box security features. So control plane apps. So these work alongside the Kubernetes app, and they give visibility into the master nodes. And this is sort of particularly useful when you're running a service like Amazon AKS, because Amazon is sort of taking the responsibility for the operation of that. But there are still some things that you might want to be keeping track of. The response times from your API servers and things. You've got something that you're running as a service, but you want to be able to maintain the visibility of the health of that service. So whether you're running a roll your own cluster, we've got an app there, but if you're using Amazon AKS, we pull the data from CloudWatch and allow you to visualize that alongside the rest of the information from the cluster as well. So Sumo has hundreds of apps. You can go into the app catalog. These are all sort of maintained by Sumo. You can download them into your environment. Once the data's going in, you can use these to sort of visualize an alert. You only need to install an app once per account, and then you can sort of share it out more broadly. But you can also have personalized copies and sort of different sort of copies for different environments and things like that if you need. So I've been talking for a fair while, and ideally you want to get your hands dirty and be able to have a play on some labs. So let's move on to that. Now, to log into the Sumo training environment, we need to go to service.sumologic.com. I can see I've got my colleague Suresh has joined us, so I might ask him to pop the URL details into the chat as well, so people can find those easily. But basically, yeah, we go to service.sumologic.com and we log in with the email address of training plus analyst, and then a 3-digit number between 001 and 999. So for example, training plus analyst 057 at sumologic.com. So please pick your own number. Once you have chosen a number and logged in, please drop that into the chat. And so ideally, everyone will use a different number so we don't end up treading on each other's toes and installing things into the same spot. The password is thanks, as in Thanksgiving. So capital T, HANKS 22 exclamation mark. So if everyone would like to try and log in there, that would be great. So you can go to service.sumologic.com. I'm already logged in here to the training environment. But yes, once you've logged in, please drop the number that you used to log in into the chat. We'll give everyone a moment there. Okay, so the first lab, we are going to install the Kubernetes app. Now, I suspect this is already going to be installed for me, but we will see. It depends when the last time they rebooted this was. So we're going to go to the app catalog. So I'll just jump over here. Now, in the left-hand nav bar in Sumo, once you've logged in, this is the home page. We can bring up the nav bar here on the left. I'm going to go down to the application catalog and click on there. And I can either search up the top here for Kubernetes. I can click into the Kubernetes section. So I can see here Kubernetes observability. I want to, so this has already been installed for me, so I can just go to explore dashboards, but I could also go to add another cluster if I wish to. But you can see here, this is giving me the, it's saying that these are already detected. It's giving me the option to create a config to install my Helm chart, but I can say that the dashboards are already detected here. So if I jump back into the app catalog, I can just go to explore dashboards here. I can see that it opens up. Oh, chat is disabled. Apologize there. My Zoom just had a bit of a hard crash on me. So just bear with me 1 second there. I haven't seen that happen before. But yeah, I got the nice little pop-up for a segfault from Apple as well. So interesting. Okay, now I think I saw a note before that chat was disabled. That's not great. I don't know if I'm able to enable that directly. Okay, attendees can chat with everyone. Okay. Can someone please try typing into the chat window for me? I'll see if that is functional now. There we go. Thank you to whoever thought to use the Q&A to say that was disabled. Okay, I shall proceed. So, had I not already had the app installed, I can install it, let it know my source category and events. Now, once it's installed, there will be the folder installed in your personal folder as well. So this is coming into it via the Explore view, but if I go down to Kubernetes here, I can see my cluster dashboard or my cluster overview dashboard. So in this case, we're going to open the folder under your personal folder, and we're going to open the cluster overview dashboard. Okay, I'll filter this down to a particular cluster. I can see what's going on at a high level where I've got any nodes not ready, any unscheduled pods. I can see anything that's running by a greater CPU or memory percentage to others. So now we're going to use the Explore view to navigate within Kubernetes. So to open a new Explore tab, I'll just sort of close what we've got open here. So from the front page, we can either click on Explore here, or we can go to New and down to Explore. And I can see here, I've got some different clusters, and it's got me already on a Kubernetes service view. Now you can see here, I've got a few different options here, and these are different ways to be able to sort of see the same sort of set of data. So if I go back to my Kubernetes service view and go to a particular cluster, and I can see here the dashboard is Kubernetes cluster overview. If I drop down, I can see some other options like Cluster Explorer or my straight up cluster dashboard. So anything which is relevant in scope to this cluster level, it allows me to see these various dashboards which are relevant in the drop down. Now, I'll give you a little bit of time here. You can sort of click on a few things. You can see here that when I click on a cluster, it drops down and lets me see which other namespaces are there. So I can see that I've got a Kubernetes dashboard namespace, and there's a couple of services that are running there as well. And I can see the pods related to that particular service. I go to the coffee bar here. I've got a Postgres database service here. If I want to, I can see that there's a couple of different containers running in this particular pod here. So I can see Postgres container and a kubestate metrics container as well. Now, we can see there's lots of different metrics coming in for these. Some pods or some things you will see are no data to display. That just means that there's not any sort of pod events or any error logs that have come through in the last 15 minutes for this particular pod. So that was just a really quick sort of introduction, sort of how we can install a dashboard and sort of use that to investigate where we've got some data in Kubernetes and sort of view that by a couple of different lenses. So now we'll sort of pivot across and talk a bit more about how we can investigate some faults and failures and use the root cause explorer. So we'll have a bit of a fictional scenario that we'll work through on how we can actually apply this in the lab environment. So this is what the root cause explorer looks like. Looks like there's a lot going on, but it's not just one of your sort of children's artworks. All of these different dots and blobs have a particular reason behind them. And up the top here, you can see some golden signals we're tracking, specifically error, availability, latency, bottleneck, throughput, success, and load. Now, some of these are what we call leading indicators, and some of these are trailing indicators. So a good example of a trailing indicator is an error. So by the time we've got an error, there's already a problem. So a good example of a leading indicator is more likely to be something like load or a bottleneck. So these happen earlier in the pipeline, and they may not eventuate to a problem such as latency or an error, but they can definitely explain them. So if we're seeing a large preponderance of latency events which correlate with some loads and bottlenecks on related servers and databases, then that's probably a really good sort of indication of why we're seeing issues grouped together. So today in our lab, you're going to take on the role of a DevOps specialist in Travelogic, which is an online travel agency. So the agency has a website and a mobile app that their customers use to book airline tickets and rental cars and so forth. The agency has a DevOps team, including analysts and software developers and security engineers. So you've newly been hired into the team. And today there is an incident. So the DevOps specialist is supporting mission critical applications on AWS, and they're using the following services: a load balancer, EC2 hosts, and DynamoDB. So the end users experienced the outage in the application with a 500 series error in the US East 1 area in the last 24 hours. So being a DevOps specialist, your challenge is to troubleshoot and rapidly isolate the root cause. So the key things we need to remember here are US East 1 region and the last 24 hours. So once again, this is exactly the same login environment. Hopefully everyone is logged in by now. But when we logged in, we're going to click on New and Explore. And in the top left corner, we're going to click on Explore By and select AWS Observability. I'll do this in a moment. So under the prod account, click the US East 1 region. So let's start from the beginning. New, Explore. And here where it says Kubernetes Service View, I'm going to drop this down to where it says AWS Observability. And so I've got a few different apps showing here, but I'm going to add to prod. That's not great. US East 1, why have we got no dashboard showing up? That's not great. Is anyone else able to see a dashboard that looks more like this when they log in? Just bear with me for a second there. I'll investigate why this is doing this. Okay, thank you for your patience there. Looked like someone had deleted something from the environment, so I needed to go and restore some dashboards quickly. So basically, where was I? So we're logged in, we're going to the prod account, we're going to the US East 1 region. So I'll do that now. New, explore, AWS observability, and yes, this time we can actually see some things. So prod and US East 1. Now I can see here things like my various activity locations, what resources are going on, where I've got API gateway errors, CPU utilization, Lambda invocations, etc. So I'm going to ensure the time range is 24 hours, and I'm going to select the application ELB namespace. So we're on 24 hours here. I'm going to go down to the application ELB namespace. So I can see things like where my request locations are. I can see I've got some stuff showing some high latency. I can see some stuff throwing some threats. But as I scroll down here, a couple of things stick out to me. So 500 requests, I can see a spike. So that, to me, is unusual. If I can see things trending along normally, and then I see a big spike in my 500 series errors, that definitely sticks out to me. So I can look at this particular entity here, Sumo Logic backup. If I open this in metrics, I can. So I can sort of see my various bits here. If I click on there, I can also see this particular load balancer. I can open that in the root cause explorer as well. So this is showing me, hey, yeah, I've got some errors on my load balancer here. It's showing as a large volume of drift. So the whoops. Showing as a large volume of drift. Now, the x-axis here, this is just wall clock time. So the y-axis is the amount of drift from the normal in the model. So this is saying that it has a 733% drift from the normal for 20 minutes. So it's something unusual in the environment. And you can see over here, it's showing up as a top contributing entity. Now, you may be wondering why there's only one thing here, and it's because we have some filters applied as to how I clicked in here. So it's looking at one account ID, one load balancer, and one region. Okay. So we can see here that, yes, we did identify that there was a dashboard with a spike. Now the question is, what caused the outage? So there's a few different ways that you can go into the root cause explorer. Now you can see here that I've pivoted into that via the entity explorer, but you can just open it directly here as well. Now, but I've only got one thing here. Now, if I remove this load balancer filter, I can still see that it exists. It's just not filtering it down to only my load balancers. I'm still looking at a particular region and a particular account, but I can see two other things. Now, this is sort of looking at a bubble chart format, which shows the amount of drift, but I can also show it in a Gantt chart format, which is nice to be able to see where related entities may be causing issues. So here I have my load balancer, which is creating errors. It has a related CPU instance, which is running on high load. So the CPU load average on this is a bottleneck. And so what I talked about before about things being leading indicators and trailing indicators, so bottlenecks can follow up with errors. Now, why is this CPU load average running hot? Well, it appears that there is write throttle events going on a particular database table. So we can click on this and we can see here. So same thing. We can see a group of grouped events here across the same namespace and instance and region, but this particular Dynamo table, big spike in write throttle events, and it's different from last day, and it's different from the last week. So this is something that's out of the norm. So we can see this particular DynamoDB table here is like Sumo Logic Kinesis connector. If I want to look at the dashboard for that, I can. So it automatically drills me down. I can see here, yeah, big spike in the write throttle events that are going on the dashboard. But basically, so that write throttle event that's going on, that flows through to what the customer sees, which is 500s on the load balancer. But we're able to stitch this together and work backwards to the underlying cause. And that's the real power of having the CloudWatch metrics being processed by Sumo to be able to sort of link these entities together and also show you where there is potential drift from the norm and underlying causes which lead to your outages. But while you're there, you can have a play about and you can click on some different filters in Root Cause Explorer. You can see any connections that you observe, and you can click through the different applications that TravelLogic application use. And so remember, we had DynamoDB, EC2, and the load balancer. So now we can talk a little bit about the actual root cause. So so we saw the endpoint, and we've managed to get to an underlying cause, and we'll be able to drill down and verify that in the metrics for the dashboard itself. So once you've sort of been able to identify a spike like that and correct it by scaling up your instance, you understand how it is particularly beneficial to have these things in your environment. So To recap, Root Cause Explorer embodies 5 concepts. Abnormal spikes, they're indicators of underlying problems. Context and correlation of spikes, and that could be the time range of an incident, or it could be a service relationship. So connections between resources and services allow us to trace to the root cause. Earlier spikes are closer to the probable cause, and associated log exploration helps us to identify the actual underlying root cause. So steps to use Root Cause Explorer: find a time range of interest based on the incident timeline. So remember, I pivoted across to Root Cause Explorer by clicking on a peak in my graph. So that's how I helped it to move into a more narrow time frame that was related. So once we've sort of got the time range, we make sure that we're looking in the right place. So relevant regions, relevant account IDs. If we want to restrict it to specific entity types, if we want to remove specific entity types, we can do that. And some of this is based on intuition, some of this is based on prior elimination. This is an engineering tool. It provides you a lot of context, but it's not magic. You still need to basically be able to follow the bouncing ball and follow your sort of gut instinct as to what makes sense. But we make it really easy to sort of find that needle in the haystack, get rid of a lot of the chaff, and be able to get into the sort of the root cause of that problem much more efficiently. So, Helm homework. Access keys and installation tokens. So this has actually been made a little bit easier now, but you can, within Sumo, create access keys. So now, depending on if you have your own Sumo instance, or if you have a commercial one, your administrator may or may not allow you to create access keys, but generally you can add an access key. And it will save it with an access ID and an access key. Now, access ID you can find again. Access key, this is the only time that you'll see it. So you need to keep it somewhere safe, like a password manager. But once you have those, you can use them for send Kubernetes data from your own clusters to Sumo using Helm. So if you wish to do this, you can see the deployment guide on GitHub. Don't worry about trying to screenshot it or anything from here, but what I would recommend is if you go to the app catalog, you can go to Kubernetes, and if you've not installed this before, it will have an option to install. If you have installed it before, you can go to add another cluster, and it will give you these commands and work you through the installation. So this is a fairly new thing we've added here, but basically you can add the Helm repo, and then it generates the command. You can generate an access key ID, and it automatically generates the commands that you will need to install your cluster. And then it'll install the dashboards and things for you as well. But yeah, if you just Google Kubernetes Sumo Logic GitHub, you can see the deployment guide and documentation for this in detail. But basically, yes, the Helm chart is very easy to install, and it allows you to have a play with your own data in a Sumo Logic account. If you do not have a Sumo Logic account, you can go to sumologic.com and click on Start a Free Trial. Choose your region. No credit card required. You'll be up and running, and yeah, you can use that account to send your live Kubernetes data to. And once you're there, you'll have these sort of Kubernetes dashboards that you're able to investigate. Check out things like what's going on with core DNS, what's going on with my NCD performance, what's going on with the health check in my control plane. So how does it work? Is it a pay-per-use basis? So just bear with me 1 second there. I'll just go back to my slides. So time for questions. So how does it work pay-per-use basis? Sumo is a we have a credit-based licensing model. So basically everything that you do is based on volume of data that you send to us. So gigabytes of logs, gigabytes of traces, data points per minute of metrics. So it's pretty straightforward, unlimited number of users. But basically, yes, you send us data and that's the cost basis. So the more data you send, the more it'll cost you, but we also make it really easy to have that data coming to us over an entire sort of yearly bucket. So you can sort of have, if you've got seasonality to your data patterns and stuff, it's much easier to work through there. But there is no cost to the initial 30-day trial. So you can there are different SKUs for Sumo Logic, but all of the applications that we've sort of worked through today, there are no additional charges to use any of these applications. So these are all included with the standard edition. So if you install Sumo, you install Kubernetes, you install CloudTrail, you can install MS SQL monitoring, Microsoft Teams, Redis, whatever you wish to sort of be investigating. These are all within the standard SKU, and yeah, it's basically just based on data volume. But if you're interested in having a more detailed chat about pricing models and licensing and things like that, yeah, please reach out to sales. So you can go to sales@sumologic.com, or if you work through the website, you can do that as well. So are there any other questions that anyone has today? No, okay, it doesn't look like we've got any further questions beyond that. So given that, I would say thank you very much for taking the time today to learn a bit more about Amazon and Kubernetes and our Sumo solution for Kubernetes observability, and a bit more about the platform in general. My name, once again, was Eddie Thompson, and I thank you very much for your time, and thanks very much to James and Suresh for helping me present today too. Okay, as we have not had any further questions, I think I shall wrap it up here. And I'll say good evening.